Welcome. Today we're doing 4.2, solving systems of linear equations by the substitution method. Okay, what if you were solving a linear system graphically and the answer was 6 over 29 and 2 over 3? Reading fractions like this off your graph would be difficult, and the answer from a graph would be an estimate at best. So other methods for solving systems are needed. The next method we will learn is substitution. This method is just how it sounds. We will substitute part of one equation into the other. So we are down to one variable and solve for the variable left. Then we will substitute the answer into one of our original equations and solve for the variable. Okay, you should probably be very confused right now. So we're going to take this out step by step. All right, solving linear systems by substitution. 1. Solve either of the equations for one variable. If one of the equations is already in this form, you can skip this step. In other words, if you have x equals 5y plus 3, you could skip it. If I had y equals 3x minus 7, you could skip it. But I don't, so I'm going to show you. This is my demonstration here on the right. Well, the second equation has a y all by itself. So I'm going to change this into y equals 1 minus 2x. Okay. Now I have it in one variable. Now, substitute the expression found in step 1, the y minus 2x. Actually, the y minus 2x into the second equation, or the first equation in this case, the other equation. So I have 2x plus 5, and now instead of y, I'm going to substitute in 1 minus 2x. All right, so now I distribute. So I'm going to have 2x plus 5 minus 10x equals 1. Now I'm going to gather like terms. So 2x and minus 10x is minus 8x plus 5 equals 1. I move the 5, and I get minus 8x equals negative 4. All right, now I divide by the negative 8. I'm isolating my x. X equals 1/2. Now I take that and I plug it back in. I have y equals 1 minus 2 times 1/2. Well, 2 times 1/2 is 1. So I have 1 minus 1. So y is 0. All right, so I end up now with my solution. It's an x of 1/2 and a y of 0. That's my solution. Okay. So we've got some examples here. 3x plus y. Notice my y already has a value. Y equals 6. I already have my substitution value. So this becomes 3x plus, well, whatever y is, in this case 6, equals 8. I subtract the 6. I get 3x equals, 8 minus 6 is 2. So my x, oops, I went too fast, I apologize. I divide both sides by 3. I can cross the 3 off. And now I have x equals 2/3. Now I plug that in. Oh, I don't have to plug that in because I already have y. So my answer is going to be 2/3, comma 6. That's my answer. All right, on the second one, number 2 here, I already have y solved for. So I'm just going to plug it in. So I have 2x plus 2 times whatever y is equals 14. Well, y is 3x plus 13. So I put that in here. Negative 3x plus 13. All right, I distribute the 2. That gives me 2x plus. 2 times negative 3 is a negative 6x. I bet you'd never know that was a negative. Okay, there we go. A bit better. Plus 2 times 13 is 26 equals 14. Well, I'm going to move the 26 over. And I'm going to combine these two. So this combines to be negative 4x. So now I have negative 4x equals negative 12. That's 14 and negative 26. I divide by negative 4. So the negative 4's cross out. The negatives cross out. 12 can be rewritten as 3 times 4. So those 4's would cross out. And I'm left with the perfectly lovely solution of x equals 3. Now I have to find y, so I plug it back in. Y equals negative 3 times x, which is 3, plus 13. That's negative 9 plus 13, or 4. So my solution is 3, 4. All right, this is how we do substitution. Now, as a hint, choose the variable you solve the equation for carefully. Try to avoid fractions and negatives. All right, and here we are. Page 2, we're going to do a few more. All right, now, I could solve for x, I could solve for y, whatever I want. Now, I think I'm going to solve for y because then I don't have to do the distribution. If I plugged an x into negative 3x, I'd have to do some distribution. So I'm going to solve for y since I have that option. So this becomes y equals 4 minus x. So I have minus 3x plus y, which is 4 minus x. And that's equal to 0. So I subtract the 4 to the other side. And I'm going to combine these two together. That's going to give me negative 4x equals negative 4. If I divide by negative 4, I get x equals 1. Now I plug that in. I had y equals 4 minus a negative, nope, not negative 1, I apologize. Just minus 1. 4 minus 1 is 3. So y is 3. So my solution is 1, 3. Remember, my solution is always a point. You have to express it this way. All right. On number 4 here, I only have one y I can solve for. The others are going to give me fractions, so I try to avoid that. So I subtract 3x on both sides. I have minus y equals 11 minus, oops, there's supposed to be an x on that, 3x. But this isn't y, this is minus y. So we're going to change that. We have to do that by multiplying all the way through by negative 1. So we get y equals 3x minus 11. It's just a convenient way of writing what was above with the negative in the best place right there in the middle. You could write it as negative 11 plus 3x. That's fine. Now I'm going to plug that into the top equation. 2x plus 5 times 3x minus 11 is equal to negative 4. I distribute. I'm going to add the 55 to both sides. And I'm going to combine those. So now I have 17x equals 51. Divide by 17. I now have x all by itself. 15 over 17 is times 3. 17 times 3 should be 51. 30. 3 times 7 is 21. Yep, that's right. Okay, so that's 3. I plug it back in. Y equals 3 times 3 minus 11. Well, that's 9 minus 11. So y is negative 2. So my answer is 3 negative 2. Put a box around it. Well, I don't like fractional coefficients. They're not pretty. So what I'm going to do instead is get rid of it. I'm going to multiply this whole thing by 2. It's going to give me 2x plus y equals negative 4. Yay! Now I can solve this for y. Negative 4 minus 2x, plug it in, minus negative 4 minus 2x equals 4. Well, this minus, when I distribute it in, I get 5x plus 4 plus 2x equals 4. I'm going to move the 4 and combine the x's. So I have 7x equals 0. Well, in this case, x must be 0. If I plug that in here, I get y is negative 4 because the negative 2x goes away. So my answer would be 0, negative 4. Okay, number 6. I'm going to take the bottom one, solve it for y. Y equals, I add 3x minus 4. I hate it when I do those weird little extra lines because on the electronically it doesn't let go. Minus 3x. Okay. So I have 9, we'll do it up here. I have 9x minus 3 times 3x minus 4 equals 12. Distribute the negative 3. Well, those add to 0, don't they? So I end up with this very odd thing. The best way to remember what this answer means is, when does 12 equal 12? The answer? Always. Forever. 12 will always be 12. Otherwise, it wouldn't be 12. So that means if it's always true, then you have infinite solutions. Okay? So this one would be, basically what that's telling you is that they are the same line. You can double check that you didn't do your math wrong by going back and looking at the system you just solved. If I multiplied this equation by negative 3, I'd get the top equation. Negative 3 times negative 3x is 9x. Negative 3 times y is negative 3y. Negative 3 times negative 4 is positive 12. Okay, the same line, therefore there's infinite solutions. Okay. Moving on to our last set of problems. Nope, just 3. Okay. (9x plus 2y equals 7). Okay, so I'm going to take the second equation and solve it for y, and then plug it in. 6x plus 2 times 2 minus 3x equals 7. Step 2 is to distribute. 6x plus 4 minus 6x equals 7. A plus 6x and a minus 6x are going to cancel. I end up with 4 equals 7. That's a problem. This should send off little bells in your head, red flags flying everywhere. No. You can't do that. When does 4 equal 7? Never. Never, ever. If 4 was equal to 7, the world would implode. So, that means never means no solution. Cannot do this. Okay? This is because they're parallel lines. They never ever cross. All right, let's look at this one. Well, looks like we can solve for the x. So we have x equals 10 minus 2y. Plug it in. 3 times 10 minus 2y plus 4y equals 8. So I distribute 30 minus 6y plus 4y equals 8. Okay, I'm going to put those two together, and I'm going to subtract the 30. Negative 6y and a positive 4y leaves me with negative 2y. And now I have 8 minus 30 gives me a negative 22. I divide both sides by negative 2. Y is equal to 11. I take that and I plug it back in. X equals 10 minus 2 times 11. Well, that's 10 minus 22, which is negative 12. So my answer is negative 12, 11. Okay. One more problem. All right. Doesn't look like it matters. But I'm very suspicious about the fact that I've got all these 4s and an 8 and a 32, but we'll go with it. All right, so I would have minus y equals minus 8 plus x. Multiply through by negative 1, y would equal positive 8 minus x. Plug that in. For x plus 4 times 8 minus x equals 32. Well, I distribute the 4. I have 4x minus 4x and plus 32. I subtract the 32. These cancel. I end up with 0 equals 0. Infinite solutions, right? Because 0 is always equal to 0. 32 will always equal 32. So I have infinite solutions. You can write out infinite or you can use the symbol. Hey, baby. All right. So we are done with 4.2. And now you should go work on your homework and then your mastery.